interest in infrastructure and boring stuff like this. Anyway, so yeah, first of all, thank you, Stole, for the introduction. Yeah, just want to also say that that last presentation was a really cool topic, a really good overview of serverless and what serverless can do, and essentially a really good overview of what you can get if you have a lot of money, what you can get if you, spend your money and throw away your cash on all of the different AWS services, because I think you'll find that the common pattern for serverless and cloud is that, yeah, you can do this, you can do that, you can do everything, right? That's the whole point. But whenever you try to add another thing, it's always, hey, there's a service for that, but wait, now that service costs a lot of money. And now it's basically like you're investing a lot into this black box that someone spent a lot of time developing and testing it and making sure that it's ready, and all the big guys are doing it, right? So it's cool. Yeah, so AWS is cool, Azure is cool, serverless is awesome. I'll be honest, I'm a big fan of serverless, of AWS, of the cloud in general as well, but I think, well, me myself, I like to get my hands dirty with a lot of things. I want to know how my code gets executed, where it exists. What happens when I, open up the address bar, type in my website? What happens then? Where does my code come from? Where does the web page load from? How do I do all of that? And I had the privilege, so to say, to start with web development in the time when piecing everything together yourself was the way to go. AWS wasn't as popular. But this isn't to say that I'm old or anything like that, or that I have too much experience. I don't. I have around 8 years of experience or so. But maybe it was just my trajectory in how I approach things. But anyway, yeah, let's get started with what the hell I'm talking about and what this engine of the web is. But Stole already gave it away, so it's NGINX and the X's because it's cool. So I typed in into ChatGPT and DALL-E and asked it, make me an image of what NGINX would be with the web and all of that stuff, and it's actually this. Looks like I don't know, a Fiat or something moving around an engine with cobwebs. I don't know what that is, but apparently it's that. So who am I? I'm Ilija, full stack developer at CodeCamp since 2017. DevOps enjoyer. As I said, I want to get my hands dirty. I want to know what the infrastructure is that my code runs on. I love open source. As I mentioned, I'm a part of the organization of the What the Stack, Base 42, and I'm super happy with how it's turning out. I'm very glad that there's so much interest and all of these amazing talks, and it's been really stressful, but also a really great experience. And I like to talk about things that I think are interesting, and maybe things that are interesting to me are boring to you, but I hope that I can tell you why they are interesting to me, and hopefully make you interested in them, because usually what interests me are these little nitty-gritty of how things work, and especially NGINX. I can guarantee you that everyone in this room, no exceptions, no matter if you're IT or not, you use this thing every day, whether you know it or not, whether you're developing applications or you're not. And one of the ideas that I'm trying to push at the moment, or rather for a while now, is trying to demystify infrastructure and DevOps as much as possible. Not that I have, the deepest knowledge of it, but as I mentioned, it's something that I really like, and I believe that I'm a full stack developer. I believe that that's the right way to go for everyone, no matter if you're a front-end developer, a back-end developer, or anything like that. Understanding every layer of the stack, at least a little bit, will help you become a better developer in whatever your main niche is, whether you're front-end, back-end, you're a Node.js developer or a C# developer, it doesn't matter, it's all the same thing. right? It's not like we invent the wheel every day, we do the same thing over and over again, whether we deploy on serverless or we deploy in the cloud. Even as you saw with Gotz's presentation, we like to force things. You know that the square goes into the circle, and that meme on TikTok for a while back. Yeah, we like to stuff things in, sometimes where they don't belong, but for a good reason. So we figured out a way to get Express, shove it into serverless, and yeah, call it a Lambda. So anyway, let me just start talking about what I actually came here to talk about, right? So let me tell you a little about the scope of what I'm talking about here. I'm going to tell you what NGINX is, how NGINX works, a little bit, and what are the common use cases. Because they told me that I have, or rather, well, part of the organization. So we decided that 25 minutes is going to be the time frame for this. So that's all I get. A little bit over, but I don't think that I can go over everything about NGINX in 25 minutes. I'm going to try to tell you as much as possible, but we'll see how it goes. So, I'm not going to tell you how to get it. I'm not going to tell you how to use it. That's a story for another time. Because how do you get it, how do you use it, depends on what your platform is and what you want to use it for. And I'm going to tell you a few ideas on how you can use it, or how you already are using it, but maybe never, took the time to check it out. So, what the hell is this engine? Already made a joke about the X thing. So, it's a web server, it's a file server, it's a gateway, a proxy, a reverse proxy, a load balancer, a mail server, an HTTP cache, and I'm gonna be honest, it's a whole bunch of things more. It's this thing. It's a freaking Swiss Army knife, and I'm not even joking, because at least me, I use this for everything. Literally for everything, and there is not a single application that I've worked on that I haven't used this application for, whether it's reverse proxying, serving static files, serving a React application, packaging a React application, whatever. In production, in development, in Docker, outside of Docker, everything. So, and we'll go over a couple of the use cases again, and we'll see, I don't know, these probably seem familiar. Gotze just went over a whole bunch of AWS services. I think you can map out a few of these. They seem probably familiar, because what is S3 if not a file server? It's just, as Gotze mentioned, serverless. If you ask 10 people, you're going to get 10 different answers. Serverless is actually not serverless, but it's just someone else's server. You don't see it, you don't care about it. And usually it works, 11 nines and all that. So S3, the file server, you have API gateway, which is the proxy, and you have the HTTP cache, which is a very, very rough idea of what CloudFront is, because CloudFront actually, you get what you pay for, because I would like to see any one of you create a CDN all across the world, and you can use NGINX for that, but yeah, you gotta pay for a lot of servers so that they're near your users, so that whenever someone from Uzbekistan loads your web app, it gets cached in the closest node nearest to Uzbekistan, rather than right here in Macedonia or something. Okay, so it's actually the most common server on the World Wide Web. It was written, by the way, if you notice, I copied quite a few things from Wikipedia, so this is not secret knowledge that I'm sharing here, but hey, it was written with the explicit goal to beat Apache. How many of you have used Apache? Good, not that many people. I have. Let me be explicit, you can beep it later, but it's shit. And it's not, I'm not saying that as in a bad way, because Apache is just a victim of it being older, and it has it has made some decisions that were okay at the time, right? It uses XML for configuration, and I'm, let's say, not that old. JSON was the cool thing when I was getting into development, and it still is, in my opinion, because it's a lot more easier to understand and parse as a human, not as a machine. XML is probably easier to make sure that it's structurally correct and all of that stuff, and it's, yeah, it was the old thing, the good thing at the time. Apache was the product of the time, and it's still a good software. It's just shit in my book, because I don't like it, to be quite frank, because it was always a nightmare to configure, and it was a start for web development for me, because you start learning about web development, you go into HTML, CSS, and JavaScript and stuff like that, and then you find out that there's this thing called backend, and then you download XAMPP, and then you figure out what the hell is this. You click start, and magic happens, and you can write PHP now, and it's the crappiest code you've ever written. Okay, I have a lot of strong opinions about the stuff that I'm talking about, but I don't hate on any of that. I've used all of that, and I keep using all of that, even PHP. So, it was written with performance in mind, so it's very, very, very performant. It's very quick. It beat Apache as well in market share. In my mind, mostly because it's much easier to manage, much easier to understand, much easier to set up. Yeah, so I made the jokes about the configuration already, and I already told you that you use it every day. On the right, you can see a sample of the configuration of NGINX at the top, and a similar configuration for Apache on the bottom. It's not that far apart, right? You can easily map out what each of the lines means, but in my mind, whenever I see the top one, it's very easy for my eyes to figure out what goes where and what means what, compared to the one on the bottom. Maybe it's just my opinion, maybe I'm just bad at servers or something, but yeah. So, let me just give you, as I mentioned, this is not the most fun presentation. It's going to give you an idea of how NGINX works. So the configuration is very, very simple. Okay, just a quick, very, very important note. When I'm talking about NGINX and servers and web infrastructure in general, I'm going to assume that you understand that I'm talking about Linux, because we don't do Windows web deployments. Even if we do .NET, we deploy it on Linux. Easier to manage, so much more documentation, you don't get vendor locked into Microsoft and all of that, pain in the stack. So, the config. One entry point, extremely simple building blocks. This is an oversimplification, but you basically need three, right? You need HTTP, you need server, you need location. This is a personal opinion, but it's very intuitive and easy to read. So, this is an actual, the simplest, dumbest config for NGINX you can have. And we mentioned that this is indeed a web server, right? So you don't even need anything else. You don't even need files. You can just apt-get install NGINX and add this to your config file, and guess what? It's going to work. You're going to get a response back whenever you open the web page, wherever it is, on port 80, it's going to listen on port 80, and it's going to return you always the response with the status code 200 for success, right? We don't do failure here, as Gotze mentioned with his lack of traces, and then the hello world in the body. This is very, very simple. I don't know if someone disagrees, but it's very easy to read. All of this, from top to bottom, is the whole config file. So, I have a very limited attention span, so when creating the presentations, it goes back and forth, back and forth. If you have any questions at any point, or you want to stop me and give me a comment or something, or swear at me, feel free to do that. But we're going to go back a little bit, away from NGINX, go on a tangent, and ask a question. What is your app? So I am referencing the previous presentation a lot, but it gave me quite a few points that I want to go over. Very rarely is your application one thing, right? That's why we have what the stack and what not what the app, right? So we have Usually the application is structured with multiple services, let's say 5 lambdas or something like that, and then you have your front-end application, which is with the framework of the day, React, Angular, Vanilla.js, Node.js, who knows what. Maybe you're writing Rust and WebAssembly, up to you. Then you have Node.js, Python, PHP, C#, and actually there could be applications, and I've seen applications that are way more than 3 of these. So it's PHP, Node.js, React, and C#, and we call them microservices. So, how do we deploy these apps? Or is that, and this is the sentence that I hate the most whenever someone says that, it's someone else's job. Someone else needs to do that. And this usually comes from people who are more oriented towards one particular part of the stack. And don't get me wrong, it's all well and good. It's fine. For me, it's just, I think, even if it's someone else's job, we should still know how to do it, right? We should still know how to clean the toilet, even if we're not professional toilet cleaners, right? Yeah, so. AI memes, the best. Yeah, let's go over the, I'm gonna just assume that we have sort of an interest in how these things work, so we're going to go over, and I'm very glad that so many of you have an interest in how these things work, so we're going to go and dive into the different use cases. So, use case number 1, as we mentioned, our own, very own mini S3 right here in our local environment, right? It's your server, you're the boss, it's not Jeffrey, right? It's you. You dictate how much you're gonna pay, you dictate where you're gonna host it, you dictate what it's going to serve. This is pretty much the most common use case. And this pretty much just, if I have to summarize it, it's going to be the second key point, right? It makes a directory on your file system accessible via the web. It can serve your images, videos, HTML, I sound like a salesman. All of your different files that you put into that directory, it serves them to whoever requests them, whether that's the browser or some application or whatever else. And usually we use it to serve our static applications, where we don't have a server-side code. If we have just a single page app like React or Angular, if you don't put it on S3, you need to host it with something like NGINX. And just a minute to take a sip of water, and we're gonna go on to the next one. Okay, yeah, and with all of these use cases, I want to also highlight the configuration. That's it. You basically just say, yeah, listen on port 80, and whenever someone asks on anything, on just slash and then anything afterwards, serve them whatever is going to be in /data/www. And just to add to this, whenever something after this goes on to, it gets appended to this path, and that's how it resolves what file needs to serve. Okay, another tangent. Yeah, I actually get surprised myself with how this presentation is flowing, because I actually did it last night, the slides. So, yeah. So, you built your application, right? For this recipe, we'll need one application, 3 services for the application, 1 domain, one server, and actually, yeah, this was written last night as well. We have 2 for microservices. So, what are our services? The frontend, myapp.com, right? Our API, because yeah, we code with React or Solid or whatever, right? It's a single page app. It needs to make requests to the backend. So the API, api.myapp.com. And let's say we have an analytics service because we don't like Google in our lives, so we want to keep control of our data, and we host that ourselves as well. So, how many of you have tried to run all 3 services on one server, and that server can also be your computer as well? Only one? Okay. That's unfortunate. Can you run all 3 services on one machine?
Yes.
Are you sure? Yeah? Oh my God, no! Okay. So, what do we... Okay, so, quick question, another question to this one. If I have an application called myapp.com, right, and I map that domain to my IP address on my server, and I type in myapp.com, and it connects to my IP, and my server is running on what port? 80, yeah, usually 80 or 443 for HTTPS. And then that's my application, right? Let's say it's an OGS app, it's the API, and it's running on port 80. That's how I can avoid, adding the comma and port in the URL. And then I start the analytics application, and it's also trying to run on port 80. What happens then?
Change the port.
Change the port, yeah. Cool. Now I need to, if I want to access the analytics, now I need to type in analytics.myapp.com. What is this? It's com? No. Com? Yeah, it's com. Com 8080. That's how we do because we're lazy. 8080. Double 80. So we usually avoid that, right? We usually want each domain to be a separate service, not each domain and port to be a separate service. And yeah, we can do that, right? Because one port per application. And then we get to use case number 2, virtual hosts. So this is a solved issue, right? This is one of the most solved issues in the history of solved issues. This is unavoidable in pretty much any use case. It's very rare that you have one machine, physical machine, and you have only one application over there, and it's only consuming that one instance of port 80 and you don't want anything else. So this is something that's introduced. I'm talking about this like I know why it was introduced. I have no idea, but I assume it's trying to reuse as much as possible for whoever decided that the lack of ports should mean only one port or something. I don't know, maybe they have no better idea. But in any case, this resolves the issue. What happens is we install an application like NGINX so that it sits on port 80 and port 443, and it basically acts as a police officer on an intersection, right? It directs the different cars or requests to the appropriate location, let's say, or to the appropriate server that needs to receive them. Server, service, whatever, right? So now you can have as many applications, as many virtual hosts, as many virtual servers on your one physical server. And that's what NGINX does. And it does this simply as well. So you have this again. Just want to reiterate on this. This is the whole config file. There's nothing else. You don't need anything else, unless I'm mistaken, but you shouldn't need anything else other than this to have, let's say, 2 applications running as is in this configuration example over here. So what we did here is we registered 2 virtual servers on one physical machine. We have 2 applications, 2 services running on different ports. Well, in this case, not running on different ports, but serving different directories. So in this case, we essentially have the admin panel of our application, which is a completely separate React app, for example, being served from /admin/www. Then we have the main application, which is the user-facing part, being served from data www. And this is pretty cool. It allows you to be your own web hosting provider, right? You can add as many websites as you want, do whatever you want with them, right? But that's usually not enough, right? We just went over the static file hosting and we just said, hey, yeah, you know what? You can do multiple of that and just map different domains. One thing that I missed is, so because the server is running on one port, the way that it differentiates which server the final request is supposed to go to, or how it's supposed to serve that request, is by checking the host header of your request. For those who don't know, whenever you send a request, at least via your browser, otherwise you don't have to, the browser actually specifies from the URL what host it's requesting it from, because in the end the communication between the client and the server is done by IP at the lowest level, right? And that means that we essentially need to specify, hey, how are you addressing this IP? And it's usually via some domain, which is the host. And okay, as I mentioned, file servers are not all the be-all and end-all of of our modern applications. We usually have APIs, we have different services. Maybe sometimes it's in Docker, maybe sometimes it's in Kubernetes, maybe sometimes it's in a completely different place. What do we need to do then? We need to reverse proxy. And essentially, this is what API Gateway does. Essentially, it acts as a reverse proxy. That's why you need to register a proxy method whenever you create an API Gateway that needs to execute your Lambda, for example. It's a reverse proxy. It sits over there, and it knows where to reach your application code, and that's what it does. It proxies the request. And it's the same thing here. Let's say we have an Node.js application, and wow, I'm sort of figuring out that we're running over time anyway. Yeah, so whenever a request gets received, it gets forwarded to your application running on some other port. Let's say Node.js application can run on port 1234 or so, 3000 or something like that. And NGINX can take the request, forward it to your app, and they will live happily ever after, even though they're completely separate processes, right? And this is also extremely useful in a lot of use cases. You usually do not want to expose your application's server directly for a myriad of reasons, but which I'm not going to go into. And this allows you the flexibility to add a lot more to the benefits that NGINX provides. We'll get to that when we get to that. But let's say I added the proxy to my API, and this is how, in its simplest form, this is going to look, right? We are still listening on port 80. We are just saying, whenever you get a request for api.myapp.com, forward that request to localhost 3000. Okay, so this is the other benefit that I almost forgot. The SSL termination. SSL termination is a very, very useful thing because nowadays we have so much pushback against pure HTTP servers and websites, and even the browsers themselves are combating against that. So we need SSL. And CloudFront can do this for you, right? It can issue SSL certificates and stuff like that, and it will help you with getting that. But as we said, we are poor. We don't have money for AWS. Sorry, Jeffrey. I want to set up SSL myself, right? And I can do that. Especially easy to set up and configure NGINX with something that's called Let's Encrypt. It's an initiative to bring SSL to the masses, essentially, and it's a non-profit that is essentially a certificate authority that you can use to issue SSL certificates for your own websites free of charge, with the caveat that it lasts only 3 months and then you have to set up auto renewals. But it's made extremely easy, especially with something called CertBot and its integration with NGINX. And this is usually what happens. So the user requests your website via HTTPS because you have secured your endpoints by providing a SSL certificate and a private key. And you only need to do that up until the NGINX instance. You don't need to do that and take care of that in your application code. You can leave your application code to be your application code and not bother with encryption. And that's a big assumption that you make, that the communication between NGINX and your server is secure even through HTTPS, even through HTTP. It's an assumption, but it's an assumption that us poor guys are willing to make. Use case 3.2, load balancing. So, your app is chunky. You need a lot of servers to scale it, right? Maybe you have one of those microservices, right? So NGINX isn't so chunky, it's relatively lightweight, as we mentioned before. So you buy one cheap server and you buy a couple of beefy ones, but you still don't want all of your traffic to go to one machine, right? You need to do what's called load balancing. And guess again, NGINX actually helps you do that, and it helps you do that in a really simple manner. So Load balancing is essentially whenever different clients make a request to your application, it needs to go to different, let's say, API servers, for example, right? And they can do the heavy lifting and the computation and then get the response back. But while the server is doing the heavy lifting, it's busy, it's tired, it's going to be difficult to perform some other operations. So that's why you need sometimes these multiple servers, and that's what NGINX helps you with. Helps you achieve this, essentially. It's very flexible on how you can do that, and essentially, and essentially you just define your upstreams, which is your different services, and it abstracts away the way that you proxy the servers to them. So essentially, I say, these are the upstreams for something that I call my backend, right? These 4 servers, right? And essentially, I just change the proxy path to be this upstream, and it automatically gets load balanced. You can even specify weights, but that's a story for another time. Yeah, extremely simple to use, extremely simple to misconfigure, extremely simple. But again, all of this stuff is extremely simple to screw up, but at least you screw it up and you learn from it, right? I promise we're near the end. So, use case number 4, and nowhere near the last, is executing app code using something called fastCGI. Okay, so we mentioned before that, how many of you are doing Node.js? Okay, how many of you are doing C#? Okay, PHP? Don't be ashamed, it's fine. We're an inclusive community here. I'm doing PHP a little bit. Oh. Yeah. But okay. So with Node.js, with C#, usually you have, how do I put this? When you start an Express application, right? You say, you instantiate the application, you say app.listen, and you specify a port, right? And that's your whole Express app. And Express actually builds upon the HTTP implementation in Node.js, and it actually hosts the whole web server as a part of your application, right? So essentially, the web serving part and your application logic is a part of the whole of the same thing, right? So when you start it, you start a process, and that process is both your application logic and the web server and the way that it handles routing, parsing HTTP, and all of that stuff, right? Same thing for C# with Kestrel, and you say whatever the syntax was. I don't remember it exactly because Microsoft changed it like 15 times. But you essentially do the same thing. You start the application, you specify a port, or it gets resolved automatically with configuration and blah, blah, blah. But it still hosts the code and the web server inside the same process. This is not the case for a lot of languages. PHP being one of those. Python being another. What else? Java actually being another. So, this is basically what I just said, so I'm not going to parrot that, but in any case, what you need in this, in cases like this, is for some web server to actually execute your code, because your code, your PHP code, is actually only your PHP code and not the web server itself, right? And so when we mentioned stateless before, you have to be careful and make sure that your Node.js server is stateless, but with PHP, you can be stateful by writing to the file system and stuff like that, but usually you don't have a concept of in-process memory, for example, and stuff like that. So it's a bit easier to be stateless and have to think about, hey, what am I going to do when I have to do whatever with, and remember this, I have to write to the database or Redis or S3 or whatever else. To go back, what NGINX helps us with here is actually executing the code. So essentially adding on to the static file serving, whenever something gets served that's actually PHP code, for example, it can actually invoke something else that's called PHP FPM, for example, which is PHP process manager, which is actually going to handle executing the code, parsing the request, and sending all of that to your PHP script. and then return the response back to NGINX. And as I mentioned, this works with PHP, Python, and all of that. So, all of this blah 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 is what I just said. This is what it looks like, because I'm feeling the pressure from Ivan just telling me, hey, you already used up the Q&A time. Hurry up. Okay, I get it. But yeah, essentially same thing as before. We just say whenever you run into PHP, invoke the fast CGI, pass through the hand over that piece of logic to PHP FPM, and just return back the result with a bunch of other magic. But yeah. So as I mentioned, it's way too much to fit into 20 minutes. I'm already 10 minutes over, and yeah, it's not just HTTP. We can go into TCP proxying. You can proxy TCP, UDP, whatever you want. So essentially what you can do is you can even use NGINX to actually proxy to some database or something like that. So you can do proxy to a database. You can proxy a UDP connection to Windows remote desktop. Jump hosts inside a private network. Don't do that, that's scary. Or you can set up a whole actual service with just NGINX. As I mentioned before, you can return whatever, right? What does this do? Can anyone tell me what this does?
Magic.
No. It's actually very simple. Let's try and open it. You know this website? If you don't, this is for free from me. It's a very cool website that actually gives you the your own IP. So if you actually curl this, oh wait, man, I don't have a terminal. If you actually curl this, you're gonna get your own IP. And if you're gonna curl echo.42.10k, you're gonna get your own IP. And that's not any application logic, it's actually just this piece of code. This piece of NGINX config, it's not even code. And this is a whole service that you can maybe put ads on and sell, I don't know. But this was this was made for base42 and some dumb use cases that we had. So, guys, I'm at the end here, and it's impossible to cover everything in a short talk. Even if I make it longer by 10 minutes, we're still nowhere near. And I don't think you even probably, I don't even think I passed over any knowledge specifically to you guys. I just hope I gave you an idea of what I'm talking about and what the use cases are, how you can use it in your daily work or hobby or anything, whenever you run into the need to do so. I'm a strong believer in knowledge sharing, so I really want to pass this on and get more people to fiddle with NGINX and suffer like me sometimes. I'm trying to make infrastructure Thursdays at base42 a thing. Hopefully someone wants to join in and do some infrastructure and build out everything manually and yeah, again, suffer. I'm usually around base42 physically and on the Discord server, so I would like to do a workshop on this. Not now, I need like 2 weeks of just rest, but after that, hopefully. And yeah, if you're interested, just join the Discord server on base42, and yeah, let's hang out, let's set something up and try to bring infrastructure to the masses, I guess. Yeah, so much for my marketing pitch. Thank you for your attention.